Howdy, welcome back. So in this video, I'm just going to kind of quick go through the questions that you posed in your email. So I just went to your assignment and I just copy and pasted the questions into this Word document, just so I'm not kind of scrolling through everything. So I kind of have everything in one spot there. All right, so the first question you asked was looking at question number 2. So in this case, we assume error is negligible unless otherwise stated. So here we're going to calculate the displacement and velocity, meters and meters per second respectively, at the following times for a ball thrown straight up with an initial velocity of 20.1 meters per second, and the point of release, so your initial position is y not equals 0, or y sub 0 equals 0 here. All right, so we have our initial velocity is 20.1 meters per second. And our initial position is 0 meters. All right. So the first one is asking for 0.5 seconds. All right. So it's going to be largely the same process for each of these parts here. And I'll try to stick mostly with equations that are given in that formula sheet. There is one more equation that I'm not sure is given in the formula sheet that is going to come in handy here. And that's the equation for the average velocity. So sometimes we represent the average with the variable with a bar over it. So to find the average of two numbers, you just add the two numbers together, divide by 2. In this case, we're taking the average of my final and initial velocity. So I'm just going to add the final velocity plus the initial velocity. I guess I use V0 here, divided by 2. All right, and again, that is going to equal your displacement over your time. All right, so to find the velocity, we have the equation final velocity equals initial velocity plus a times t. All right, where in this case, we're assuming that So we're assuming that we aren't acting to accelerate the object up in any way. So we're just starting off with initial velocity, and then we're letting gravity take control. So in this case, a is going to be the acceleration due to gravity, which is going to be negative 9.8. All right. So when t equals 0.5 seconds, we have my final velocity is going to be my initial velocity, which is 20.1, plus a negative 9.8 times t, which is 0.5 seconds. So when we take 20.1 plus negative 9.8 times 0.5, we end up with a final velocity of 15.2 meters per second. All right. So that means once I have the final velocity, so I know the final velocity and I know the initial velocity, so I can find my average velocity. So for the 0.5 seconds, the average velocity is going to be 15.2 plus 20.1 divided by 2. By 2 plus 20.1. divided by 2. So I end up with an average velocity of 17.65, which again, that is going to equal my displacement divided by the time, which again, the time is 0.5 seconds. So then find my displacement. So to undo the division here, I can just multiply by 0.5. Take 17.65 times 0.5. I end up with 8 points. So I end up with a displacement of 8.825 meters. And again, since my initial position is 0, my displacement represents the total amount of distance that I've traveled. All right, and that's kind of the process that you can go through for every single one of these first couple here. So at 0.5 seconds we have that. So at 1 second, So again, we can find our final velocity by taking our initial velocity, which is 20.1, plus my acceleration, which again is my acceleration due to gravity. So again, that's a negative 9.8 since it is initially starting being thrown up at 20.1 meters per second, but gravity is acting in the downward direction. So that's why we have negative for our acceleration due to gravity there. And in this case, we have after 1 second. So yeah, so if take 20.1 plus a negative 9.8 times 1, I end up with 10.3 meters per second for my final velocity. All right, so again, we can find our average velocity. So that's going to be 20.1 plus 10.3 over 2. So 20.1 plus 10.3. 15.2. All right. And again, we can take my delta y is equal to my average velocity times the change in time. So we have 15.2 times 1. So my final position, so my change in position is 15.2, which again, my initial position is 0. So that means that my final position is going to be 15.2 meters. All right, I'll go ahead and zoom out the webcam here so you can kind of see the entire thing here. All right, so at C, we have after 1.5 seconds, all right, so again, we're just going to follow the same process. So again, you have our VF is equal to my initial velocity, which again is 20.1, plus a negative 9.8 times T, which is 1.5 seconds. So you have 20.1. plus a negative 9.8 times 1.5, and 5.4 meters per second. And again, we have my average velocity is going to be my initial velocity plus my final velocity over 2. So we have 20.1 plus 5.4 divided by 2. Yeah, my average velocity is going to be 12.75, which again, my change in position is going to be my average velocity times the change in time. So you have 12.75 times 1.5. So you end up with 19.125. meters, and this is in meters per second. All right. And then finally, the last one is after 2 seconds. So yeah, so again, we have our final velocity is equal to my initial velocity, which again is 20.1, plus negative 9.8 times 2. And put 0.5 meters per second for my final velocity, which again, my average velocity is 20.1 plus 0.5 over 2, which would be 20.6 divided by 2, so that would be 10.3, which again, change position is equal to my average velocity times the change in time. So you have 10.3 times 2, which is 20.6 meters. So yeah, so that's kind of it for the first one. So again, the main thing that I don't think I've mentioned yet, but is probably kind of an important formula to know, is that the average velocity, again, just like the average of two numbers, you just add the two numbers together, divide by 2. All right. Okay, so let's see what the next one is here. All right. So the next one here, and we're going to continue using the average velocity equation as well. So again, kind of an important thing to know there. All right, so the next one here, so we have an object is dropped from a height of 71.5 meters above the ground. Again, assuming air resistance is negligible. So the first step was to determine the distance in meters traveled in the first second. So you put down 4.9 meters, and that's correct. Great job. All right, so the next one says determine the final velocity at which the object hits the ground. All right. So yeah, so in this case, so I wrote down all the questions beforehand, so I kind of knew what I was getting myself into here. So yeah, so to start off, we're actually going to start off by finding the time, and then once we know the time, we can calculate the final velocity. Yeah. Yeah, all right. So yeah, so we have the change in my displacement is equal to 1/2 AT squared, because assuming our initial velocity is 0. Which is true in this case, so we're just dropping it, so we're not like throwing it down. We're just dropping it, so my initial velocity is 0, and then all the change in velocity is from the acceleration of gravity there. All right. So yeah, so in this case, we're asked to find it when it hits the ground. So when it hits the ground, if it started off at 71.5 meters above the ground, so when it hits the ground, it has traveled negative 71.5 meters. So it's traveled down 71.5 meters here. So you have negative 71.5 equals 1/2. And then the acceleration due to gravity is negative 9.8 times t squared. All right. So yeah, so you have negative 71.5. So if you take 1/2 times negative 9.8, so that's going to be negative 4.9 t squared. So then we can divide both sides by negative 4.9, negative 4.9, which gets me t squared equal to 71.5 divided by 4.9. 14.592 it looks like. All right, which again, to figure out what t equals, so to figure out how long it took to travel that distance, I can just take the square root of both sides. So the square root and the squared cancel out. So we have t equals the square root of 14.592, which is about, take the square root and square root of 14.592. End up with 3.82 seconds. All right, so again, that's how long it took to travel there. And again, we have, from the previous one, we have our final velocity is equal to my initial velocity plus a times t. So yeah, so in this case, my final velocity, again, my initial velocity is 0. Since again, I'm dropping it, I'm not throwing it down. So So yeah, so my initial velocity is just going to be 0. So we have negative 9.8, again, the acceleration due to gravity, times the time, which is 3.82 seconds. So negative 9.8 times 3.82. So we end up with negative 37.436 meters per second. And oftentimes for these questions, it asks you just to find the magnitude. So the magnitude is going to be just 37.436. Again, the negative means that it's moving downward, so it's speeding up in the downward direction, if that makes sense. All right. So that is B. So this would be C here. So determine the distance traveled during the last second of motion before hitting the ground. All right. All right, so in this case, again, we're going to be using the absolute value equation. So to start off, we're going to find our initial velocity. So in this case, we know the final velocity. That's what we figured out in the previous question. That's going to equal my initial velocity plus a times t, where my initial velocity isn't actually the initial velocity at the start, but it's actually the velocity 1 second prior to hitting the ground. So so you can think of this as the before velocity, and this is the after velocity, or the prior velocity followed by the subsequent velocity there. All right. So in this case, we have the final velocity is what I found in the previous question. So we have negative 37.436 equals my prior velocity plus negative 9.8. And again, I'm looking for the last second before it hits the ground. So that prior velocity is the velocity 1 second before it hits the ground. So my time is 1 there. All right. So negative 9.8 times 1 is just going to be negative 9.8. So in this case, to find my initial velocity, I can just add 9.8 to each side here. So in this case, it is kind of important that you include the negative sign for velocity. Otherwise, you are going to get an incorrect answer there. So my velocity 1 second before hitting the ground is going to be negative 27.636. All right, so then to find my displacement, again, I can just take my average velocity times the time, and that's going to equal my displacement. All right, so my average velocity, again, is going to be the sum of my two velocities divided by 2. So we have negative 37.436 plus a negative 27.636 over 2 times 1 equals my displacement here. So negative 37.436 plus negative 27.636 divided by 2. So we end up with negative 32.536. So you have delta y equals negative 32.536. And this is in meters. And again, the negative, oftentimes, again, it's asking just for the magnitude. So if it's just asking for the magnitude, you can just do 32.536. But the negative means that it's traveling downward. So it's moved down 32.536 meters. All right. So the next one here is 7. All right. So there what you throw a ball straight up with an initial velocity of 15.7 meters per second. And it passes a tree branch on the way up at a height of 6.96 meters. So how much additional time in seconds will pass before the ball passes the tree branch on the way back down? All right. Okay, so full disclosure, this question is kind of dealing with something that I didn't necessarily hit on in the notes because, again, I'm kind of using what a previous instructor has kind of gone through, so it's a little bit slightly different than how I would necessarily teach it. So this, I hit more upon this last spring when I taught this course on ground. So I'll try to kind of, so I won't, this question like this won't necessarily be on like an exam or anything, but since you asked, and I don't know, I think it's still kind of nice to know and important to know there. So I'll go ahead and just quickly go through it. Well, maybe not quickly, but I'll go through it here. All right. And again, I'll try to stick with formulas that we are given in there, and again, using the average velocity formula there. All right. And again, I'm looking for when it passes 6.96 meters. All right. So when you throw something up, it follows a path that's known as what's known as parabola. So if you have 6.96 meters, if that's like right here, it is going to pass through it twice. So we're trying to figure out what this time is. All right. So again, just kind of giving you ideas, kind of what we're looking for, and saying, yes, there is actually, the question does make sense there. All right. Okay. So again, if we have my change, my in displacement is equal to my average velocity, so that's v final plus v initial over 2 times my time. I've used that in the previous questions there. So multiplying by 2, so we have 2 times delta y equals vf plus v naught times t. Unfortunately, in this case, I don't know time and I don't know my final velocity. So that's kind of the one thing that makes this question trickier than the previous ones. So other than that, I do know kind of what distance I'm looking for, and I do know my initial velocity, but again, since I don't have final velocity or time, I can't necessarily solve for anything using this equation alone there. All right, but again, we do also have that my final velocity is equal to my initial velocity plus at. So I can plug this in. So that gets it so where I just have one unknown value. So I just don't know the t in this case. So you have 2 times delta y equals v naught plus at plus v naught times t, which equals 2 times my initial velocity plus at times t. So in this case, we have 2 times delta y is equal to 2 times my initial velocity times time plus my acceleration times time squared. All right. So now I'm going to go ahead and plug a few things in. So again, my displacement, I'm looking for when it passes 6.96. So my delta y is going to be 6.96. So if I take 2 times that, I end up with 13.92 equals 2, and my initial velocity is 15.7. So if I take twice that, I end up with 31.4 times t. And then, again, my acceleration is the acceleration due to gravity, so we have minus 9.8 times t squared. All right. So yeah, so this is what's known as a quadratic equation. It's a quadratic equation because you have a variable squared. So first step in solving a quadratic equation is getting what's known as standard form. So standard form means I have everything on one side equaling 0 on the other side. So here I'm going to add 9.8t squared to each side and subtract 31.4t from each side. So we have 9.8t squared minus 31.4 times t minus 13.92, or sorry, plus 13.92 equals 0. All right, and then if you have a quadratic equation, you can use this as a quadratic formula. So if you have at squared plus b times t plus c equals 0, then I have t equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, so in this case, my a is 9.8, my b is negative 31.4, and my c is 13.92. So yeah, so in this case, I have t equals negative 31.4 plus or minus the square root of negative 31.4 squared minus 4 times a, which is 9.8, times c, which is 13.92, all over 2 times 9.8. So then simplifying things, I end up with 31.4 plus or minus the square root of 440.296 over 19.6. All right, so in this case, I'm going to get two answers, one for when I do plus the square root and one for when I do minus the square root. So the plus square root gives me the answer of 2.67 seconds. And when I do minus the square root, I end up with the answer of 0.53 seconds. All right, so again, these represent the 2 times at which it passes 6.96. So 0.53 is how long, at which time it passes on the way up, and then the 2.67 is what time it passes on the way down. So then to find this distance here, you're just going to subtract the 2 from each other. So we have 2.67 minus 0.53, which is going to be 2.14 seconds. All right. Again, that's probably more complicated than what I'll ask you for like on an exam or something like that. But again, since you asked, there's how I go about solving that. All right. All right. So the next one here, so question 12. Says calculate the approximate number of atoms in a bacterium. Assume that the average mass of an atom in the bacterium is 10 times the mass of a hydrogen atom. So the mass of a hydrogen atom is on the order of 10 to the negative 27th kilograms, and the mass of a bacterium is on the order of 10 to the negative 15 kilograms on there. All right. So yeah, so what I ended up doing is I ended up finding kind of how many quote-unquote hydrogen atoms go into a bacterium atom. So yeah, so in that case, what you can do is you can take 10 to the negative 27th and divide it by 10, wait, other way around. So yeah, so it's 10 to the negative 15th, and divide that by 10 to the negative 27th. So yeah, so again, we're looking for how many times 10 to the negative 27th fits into 10 to the negative 15th. So when we do that, what we can do is we can move this one up to the top, or if you will, if you have two things that are exponents that have the same base and you're dividing them, what you can do is you can subtract the exponent in the bottom from the exponent in the top. So you have 10 to the negative 15th minus a negative 27. So that's going to get you negative 15 minus a negative 27. So again, when you subtract the negative, that's going to turn into plus 27. So that's going to get you 10 to the 12th. All right. So that represents how many hydrogen atoms would fit inside a bacterium. All right. Now, the mass of an atom in a bacterium is 10 times the mass of a hydrogen atom. So yeah, so if we had 10 hydrogen atoms could fit inside a bacterium, again, that means that the bacterium there's only one atom of the bacterium. So we're going to take the number of hydrogen atoms in bacterium and divide that by 10. So we're going to divide this by 10. And again, this is like 10 to the first. So again, we can do the exact same thing that we did over here. So this is going to be 10 to the 12th minus 1, or 10 to the 11th, which I think is the correct answer on there. All right. And finally, the last one here. All right. So yeah, so here we have a velocity versus time graph. So the graph is shown for a world-class track sprinter in a 100-meter race. All right. So yeah, so again, the average velocity, again, as mentioned before and as used previously, the average velocity is going to be your final velocity plus your initial velocity divided by 2. So for the first 4 seconds, your final velocity is 12. And my initial velocity is 0. So yeah, so we have 12 up there for my velocity after 4 seconds. And for my initial velocity, I have 0. So you have 12 plus 0 over 2, which is going to be 6 meters per second. All right. So the next one is asking, what's the instantaneous velocity at t equals 6 seconds? All right. So yeah, so 12 meters per second. I assume that you read the graph and looked at 6 and then looked for the velocity, which is perfect. So 12 meters per second is the correct answer there. The average acceleration between 0 and 4 seconds. So I'm assuming that you took the change in velocity divided by the time. So yeah, so in this case, your change in velocity is 12 minus 0, which would be 12, divided by 4 seconds, which is 3 meters per second squared, which is correct there. So yeah, so the final one is asking, what is their time in seconds for the race? All right. So yeah, so in this case, we're kind of going to talk about it in 2 separate parts. So yeah, so we're going to talk about the first 4 seconds. And then the last however many seconds. That's kind of going to be kind of what we're hoping to find out here. All right. So yeah, so for the first 4 seconds, we want to figure out the distance that they traveled. So again, distance, or the displacement, is going to be your average velocity multiplied by your time. So again, we found out previously in part A that our average velocity was 6 meters per second. So if they've done that for 4 seconds, that means that for the first 4 seconds, they've traveled 24 meters. All right. So yeah, so again, we take our average velocity multiplied by the time here. So that gets us the distance that they traveled in the first 4 seconds. All right. So again, it's a 100-meter race. So that means in the last how many seconds? They've traveled 100 minus 24, which is 76 meters. And for that, they've kept a steady pace of 12 meters per second. So if they've gone 12 meters per second for 76 meters, all right, so yes, we have 12 meters per second. And again, that's going to be times time is going to be 76 meters. So then we're going to divide both sides by 12. So that gets me a time of around 6.3 seconds. All right, so then we're again asked to find the total time that it took for them to run the race. So if you take 6.3 plus the first 4 seconds, that gets me a total time of 10.3 seconds. All right. So yes, hopefully that helps clarify a few of the things for you. Yeah, hopefully you found this helpful. Yeah. In the meantime, have a lovely day, and I'll talk to you later. Bye now.